Okay, so what I want to do to get started is to show you the awesome power of coroutines and yield, and these are features that we can call upon in our C# scripts to create timed and delayed behaviors for objects in our game. What we have in front of us here is a terrain scene that is included in the course files. It is a scene that I've gone ahead and created here. The terrain is not absolutely essential for our purposes, but I have created it to give us a backdrop that is a bit more pleasant to look at than the default empty Unity scene that we get when we create a new scene. So if I zoom in a little, you can see that I have here 4 colored boxes: red, blue, green and yellow, and I also have a first-person controller on the hillside here. Now, to show you how this works, I'm just going to press play on the toolbar and then take a look at the 4 boxes. You can see that the yellow one raises into the sky, then the green, then the blue and the red. And each box waits for the previous one to raise before moving itself, and so they all raise into the air one after the other in a sequence. Now, this sequence behavior that takes place across many frames and across much time can be created in different ways in Unity. One way we could create it is to create a new script file, add a new update function, and in the update function we create all kinds of transformations, raising each of these cubes into the sky. Of course, we would have to add extra variables and conditional statements to make sure that they all raised one after the other in sequence. So we'd have to have some kind of variable that was set when the yellow one had reached the top of the sky, and then it was time for the blue one to move, and so on and so forth. And really, this kind of setup can easily become very complicated, and we can end up spending a lot of time coding this functionality. Well, Unity provides us with a shortcut method, which is called coroutines and yield. Now, coroutines are a special kind of function in Unity. We can create as many of them as we want in our files, and we can mark each of those functions as a coroutine, and they differ from standard functions because coroutines act like threads or asynchronous functions. They're the kinds of functions we can run and almost have them run in parallel or alongside all the rest of our code, so that during our game the function appears to be running at the same time as everything else. This offers us a very powerful ability, the ability to be able to create timed and all kinds of sequence behavior and to contain all of that code inside one single function rather than spreading it across multiple functions. So what we're going to be doing next is having a look at how we can create a coroutine to replicate this rising cube setup that we have here.